Hey everybody, today it's solving systems using substitution. This is chapter 6 and it is lesson 2. I'm not sure which is my jam, but I have to say that this one is kind of cool too. I kind of like the graphing, the picture way of solving. I also sort of like the numbers way of solving too. I think it feels good on the brain to use the logic. But let's go ahead and see what this looks like. So in this case, what is the solution of the system? Use substitution. Y equals 3x, and I have x plus y equals negative 32. What's nice about substituting is that I don't really have to worry so much about slope-intercept form. So I can just leave these equations the way that they are and plop in the numbers. So in this case, if they're telling me that y equals 3x, well, I can actually substitute in this problem, and I can plop in y, I can put in 3x for y. And then I can simplify and solve the problem. So what is 1x plus 3x? That would be 4x. And 4x equals negative 32 is what is left. And then all I have to do is divide. 4 divided by 4 makes that go away, and that'll leave me with the next term. Then I divide this side by 4 as well. And what is x divided by, or I'm sorry, what is negative 32 divided by 4? I hope that you pulled out your calculator and you typed that in, or you just knew it off the top of your head. Negative 32 divided by 4 is negative 8. And that is the final answer. X equals 8 for x. Now, I could actually come back up and figure out what y equals too, couldn't I? I would have to, so in order to do that, sorry, this is actually not the final answer. There's more to do. So now I could come up and I can plop in negative 8. Let me use a different color because now we're coming into the second phase of the problem. If I plop in negative 8 for this one, and then I still have a y, I have to figure out what my y is. So if I have a negative 8 here, I'm going to have to add an 8 to this side and add an 8 to this side. Negative 32 plus 8 is negative 24. So really the solution, it really needs to be in the form of a point on a line. It would be negative 24 on this side and negative 8 on this side. This would be your final answer. Let me just double check the book and make sure that I am thinking that through correct. I am thinking that through exactly correct. Okay, let's move on to the next one. What is the solution of this system? In this case, I don't have a y value that is determined. I have to go ahead and figure out what that is just by rearranging the equations or solving for a variable or whatever, isolating one of the variables. I like that this y is already by itself, so I won't have to do any dividing. I'm going to try and get this y by itself so I can figure out what it is. To do that, I have to, this negative 2x, if I add a 2x, it'll plop it to the other side. That would be ideal. If I add a 2x, then that would be y equals, I could put the 2x here, then it would be actually in slope-intercept form, but that is not the point. But 2x minus 3 is there. So now I can take this here. I'm going to put parentheses around it so that we can remember that this is what y equals. If I plop this in for y in the other equation, I should be able to figure out what x is. So I'm going to plop in 2x minus 3. Okay, so now I'm going to go ahead and solve for this. I'm going to write it over here. What is 3 times 2? We got to use the distributive property to get rid of these parentheses now. 3 times 2 is 6x. And 3 times 3 is negative 9. 3 times negative 3 is negative 9. And then I still have a plus 4x equals 14. I need to combine my x terms here. What is 6x plus 6x? Did I say that right? What is 6x plus 4x? That would be 10x. Looks like I still have a minus 9, so I'm going to bring down that minus 9. Equals 14. I also will need to get rid of this 9. I need to get x by itself. So I'm going to get rid of this 9 here by adding a 9 so that that equals 0. Add 9 to one side, got to add 9 to the other side. That 14 plus 9 in my head, well, 14 plus 10 is 24, so I'm going to go down by 1, 23. And I still have 10x. So I'm going to divide by 10. Alrighty, so in my answer, I'm going to have 23 over 10 for x. (23/10). And then I'm going to put a comma there so that I'll have my y. So I'm going to take this 23, I'm going to plop it back in for my x. Let's put it in this guy here. 23 over 10. Got to figure out a y here. So 2 times 23 is 26. It's actually negative 2 times 23, so that's going to be 26. I'm going to put this one over here. 26. It's a negative 26. And then I still have 10. Then I am going to, then we're going to put a plus y equals negative 3. Alrighty, I got to get this y by itself, so I'm going to go ahead and add 26 over 10. So that comes out to be 0. And 3 plus 26 over 10. Well, I have a denominator issue. I can't add anything with different denominators, so we have to make them both the same denominator. So I'm going to multiply this side by 10 so that it has the same denominator as that side. If I multiply the bottom by 10, I got to multiply the top by 10. What is negative 30 plus 26? If you said negative 4, good job. Negative 4 over 10 is what y would equal. I can reduce that down to 2/5. So that is what I'm going to report. I'm going to actually put it right over here. 2/5. And those are the answers right there. Final answer. That is where this is what would work in both of these for both equations. Anomalies, infinite solutions and no solutions. Use substitution. So let's try this one. We'll see if we need to, oh yes, we will. All right, so x equals negative 2y plus 4. It's nice when they just tell me what x equals, then I can plop it in. All right, 3.5 and I'm going to take this here, this is what x equals, and I'm going to plop all of that in the parentheses right inside this x here. Negative 2y plus 4. And I still have a plus 7y. All right, 3.5 times negative 2. Pulling out my calculator here. Clear. 3.5 times negative 2 equals negative 7. Y. And 3.5 times 4. Looks like 14. Oh, I already see it. Do you guys see what happened? Oh, no. All right. Here's the problem. I'm trying to solve for y, but what happens when I have minus 7y plus 7y? They zero each other out, and all of a sudden, my y is completely gone. And it will be true that 14 will equal 14, but it's not enough because I still didn't, by doing the numbers, I didn't figure out what y equals. So really, I could have any number. I could put a 2 inside this. I could put it, if I were to put a 2 here, would it be true? This would be negative 14 plus 14, that would be 0, and 14 would still be 14. So it's going to be, that's going to be true. I could put in a 5. Negative 7 times 5 is 35, is negative 35, and 7 times 5 is 35. That equals 0. Negative 35 plus 35 equals 0. So, and 14 will still equal 14. So that means any number that I put in for y will always end up being true. So this one has an infinite number of solutions. It looks a little bit different when there are no solutions. So let's go ahead and figure out what that one looks like. Y equals 3x minus 11. Well, I'm going to take that 3x minus 11, I'm going to substitute it in and see what happens. So if I have 3x minus 11, I'm going to plop it into this run here. That way we are all good to go. 3x minus 11 in the space of y. I'm going to leave out the parentheses because I don't have any coefficients here to multiply into it. I'm just going to write it out. (3x minus 11 minus 3x). This one is a problem because look what happens. These also come out to be 0. But notice that what happens when I zero, if this guy is gone and this guy is gone, I have negative 11 equals negative 13. Is that a true statement? Does negative 11 equal negative 13? No, it does not work. There is no solution that will solve these two systems. So this one has no solution. It sort of comes out to look the same because while the variables do cancel out in both cases, notice that 14 does equal 14. That's a true statement. But in this one, negative 11 does not equal negative 13. So it's the opposite problem. It has no solution. All right, that is solving systems using substitution. Substitution is a very helpful way to solve systems. We have some practice to do. I want you to get after it and do your best.